The first topic is over differential equation, and the question is giving you dy dx as the differential equation. On part A, the slope field is given to us. We need to draw two different solution curves onto the graph itself, which will provide it to you in the booklet. The first solution curve must go through 0 and 2, and if you notice, in order to go through 0 and 2, the slopes are 0, which means we're going to just draw a constant line. The solution curve must go through from edge to edge without drawing any arrows because we don't know what happened away from this slope field. So this will be the first curve it looks like. The second curve must go through the point 1 and 0. If you notice at this point, the graph is increasing and concaving down, but that's not enough to draw. We still have to follow the flow of the curve where the slopes are. And then looks like a bell shape kind of thing. So I'm kind of going to redraw this nicely. The second solution curve, this is going to be decreasing and concaving down here, and then concaving up. Kind of, again, follow the concavity, going through the initial value and increasing, concaving down. And that is the second solution curve. On part B, we need to find this equation of tangent line and then use that to approximate the f of 0.7. So the first thing I do is to find the equation of tangent line, which we need x1 and y1. The x value is at 1. That is what they're asking us to do, which means we do have a y value. 1, 0, it is given in part 1, right here, the initial value. So that's our x1, y1. We also need to know the slope at x equal 1, which is the dy dx. With a bar, this is the correct notation. At 1, 0, it is a order pair. So we're gonna plug into this equation right here as x equal 1 and then y is 0. I do not recommend you to do safe stop here because we have to use that to do equation of tangent line and the approximation. So this will be a 4/3 if I compute. And now, when we do the equation of tangent line, we have y minus y1, the slope 4/3 derivative, multiplied by x minus x1. Using that to approximate f of 0.7, which means x is 0.7. So y will be 4/3, 0.7 minus 1. Now that's not the final answer because we need to tell what the AP grader y is. And in our case, y is f of 0.7. And then you need to use the approximation symbol because this is a approximation. And then allowed to use safe stop. So I will leave you answer like this. If you do compute it, the estimation will be negative 0.4. In part C, we need to find the particular solution, y equal f of x, which means we need to integrate it, and then we need to, first of all, separate the variable. So dx should be on the other side of the equation, and then the y minus 2 should be on the left-hand side of the equation, which means we need to divide. So when I separate them, it will look like dy over y minus 2 squared. On the left, on the right-hand side is 1/3 x dx. Don't forget to write the integral symbol. When you do the antiderivative, the left-hand side looks like we need to do a very simple u sub. When you do u sub, I recommend you to do u sub on the side for the AP grader to take a look. Now, sometimes you can also do u sub in your head if you feel confident with it. In this question, it is gonna end up with du over u square if I'm doing the u sub, which applying the power rule here, u to the negative 2 du. Now, obviously going back to the variable when you do the integration, which will be negative u to the negative 1, which is negative 1 over u. And in our case, u is y minus 2. The right-hand side when I do the integration will be 1/3 times 1/2 x squared plus c, which you can rewrite as 1 over 6 x squared plus c. And now we're going to plug in the initial value 1, 0 to find out what c value is. When you plug in 0 for the y value, this will be 1 over negative 2, but negative will be 1/2. Plugging 1 for x is 1 over 6. We're going to find the c value, and in this case, c value is 1/2 minus 1/6. Again, I do not recommend you to do safe stop here because we need to find the actual y equation. So this will be 2 over 6 you can leave it unreduced, which is fine, or 1/3 for C value. And now we're going to plug in back to the equation that we already have. So it will be a negative 1 over y minus 2 equal to 1 over 6x squared plus 1/3. We're going to solve for y because this is not done. So the first thing I will do is change everything divided by -1 because our left-hand side is a negative. The right-hand side will now becomes a negative 1 over 6x squared, subtract 1/3. We're going to reciprocal next, so y minus 2 is going to be 1 over all of that. Again, just do safe stops. Don't need to simplify your fractions. It is okay to have mixed fractions on the AP exam. And all you need to do is to add 2 to both sides, which is going to be our final answer. And now let's talk about the points. The first point, part A, is going to be just 2 points by drawing 2 different solution curves. Part A. And then part B, you're going to get 1 point for writing the correct equation of tangent line, and then 1 point for the correct approximation with the correct notation. Part C has 5 points. The first point will be awarded for just separating the variables. The second point and the third point will be awarded by doing the correct antiderivative. And the next one will be the constant of integration, so which is the C value. And then to finally getting y by itself, this will be the last point you're going to get for this FRQ. Next is 2019 FRQ. We are giving a cylinder and then it's telling us the diameter is 2 feet, which we know the radius is 1 feet. Collects the rainwater. It is also telling us the rate of change of height h with respect to time is modeled by this highlighted equation dh dt. And then it is measured in feet per second. In part A, we are looking for the rate of change of volume with respect to time, and then it is giving us the volume equation. This reminds me to do the implicit differentiation with the related rates, which we're going to do is taking the derivative with respect to time on the left-hand side and taking the derivative with respect to time on the right-hand side. The left-hand side will become dv dt, which is exactly what we're looking for, the rate of change of volume with respect to time. The right-hand side we're going to do is a product rule, fg prime plus gf prime. When you're taking the fg prime with respect to t, we're going to get pi r squared. The derivative of h will be dh dt because we are taking the derivative with respect to a different variable, plus a gf prime. G will be hf prime will be 2 times r times pi, which is 2 pi r. And don't forget, this time we are taking the derivative with respect to r, which we need dr dt, times by h. That's going to be my product rule. And now we're going to plug in everything we know. The radius at the instant will be 1 feet. It is given at the beginning of the paragraph. We also note that h is 4 feet from part A. Which also can plug into this dh dt equation, which is highlighted in yellow here. dh dt, when we plug in, it is negative 1 over 10 multiplied by square root of h. H will be 4 at the instant. What do we not know is the dr dt. However, when you're looking at the picture, the radius is going to stay the same. The height is the one that's decreasing when you're draining out the rainwater, which means our dr dt is not changing. When something is not changing, then the derivative with respect to time will be always 0. So in this part, this guy's dr dt is 0, so which means that we do not need to compute the second part of our product rule. We just need to plug in everything to the first part. And dv dt is going to be pi times r, which is 1. dh dt, I'm going to use safe stop by plugging negative 1 over 10 square root of 4. And if you do that, you can just stop here and using the correct units. Our volume is in terms of cubic feet. Our time is seconds. This is rate of change. So the correct unit will be cubic feet per second. Part B is giving us the height of the water is 3 feet and asking us if the rate of change of height with respect to time is increasing or decreasing. So we do have a tool called the Calculus House, can help you remind you how to justify our answers. If we want to prove the rate of change is increasing or decreasing, we need to show f double prime is positive or negative. And in this case, f double prime will be the derivative of dh dt. I have rewrite dh dt as negative 1 over 10 h to the 1/2 power. This way it's easier to do the power rule. So we are taking the derivative with respect to t of dh dt again. That will give us d squared h over dt squared, the second derivative. To apply the power rule, it will be negative 1 over 10 times 1/2, which is negative 1 over 20 h to the negative half power. Because we are taking the derivative with respect to t, again, we need to have dh dt. Now, we do not want to leave our answer like this. We don't want negative power. We don't want to have dh dt again. You need to replace dh dt by what the equation is, because we need to compute the second derivative when h is 3 to see if they are positive or negative. This way can show that f prime is increasing or decreasing. So therefore, I'm going to rewrite our second derivative as negative 1 over 20 h to the 1/2 power. You can put it down here. dh dt will be the original equation, negative 1 over 10 square root of h. Now, you don't have to compute what the second derivative is exactly. We just need to know whether they are positive or negative. And in our case, the height of the instant is 3 feet. When you plug in 3 in here, we just need to know that this is a positive number. I will not waste my time to compute the second derivative itself, since d squared h over dt squared at h equals 3 feet is greater than 0. We can say the rate of change, which is the derivative, the rate of change of height, can just pretty much copy the question, is increasing when the height of water is 3 feet. Here are the point distribution for part A and part B so far. I want you to try part C yourself first to see if you can earn all 4 points here. Now check your answer. This is the correct answer for part C. You should get a C value of 2 root 5, and the final equation for h of t, don't forget to write the correct notations, will be this quadratic function right here.